Okay, hello, and welcome to today's edition of Eiffel. This is not the first. Well, this is the first, but it's not beginning at the start. Um, so Eiffel is a kind of JS implementation of parts of Filecoin and maybe Filecoin or Lotus version in some way ported in the future. But my immediate goal is to get actors up and running and a VM that can execute messages. And my idea is that I would like to be able to execute the test vectors against this. And so the test vectors are implementation independent, they're just JSON files, but they encode the kind of state before a bunch of messages have been executed and a state after a bunch of messages have been executed, so that you can check that your implementation is doing the right thing and is compliant. So that if it were ever to be on mainnet and working, then the whole idea is that it should stay in sync and not and be in consensus with everyone else. And so to do that, I need an actors. So I've started a little bit of work on that. There's some really small actors which have been done. And I'm currently working on the power actor because that's a sort of medium-sized actor. I mean, it's still pretty big. So once we have actors done and implemented, we can implement a VM and then start executing messages from test vectors against it. And that would be super cool. And then from there, if we're able to be compliant, then I would love to get libp2p involved, start listening on the pub/sub topic for Filecoin messages, and start trying to follow the chain in JS. So that would be rad. Eiffel is, so this is kind of looks like a little bit like the Eiffel Tower. I like how this logo looks a little bit like some sort of Japanese writing, which is sort of, I guess, a homage to Lotus. The name is not great. I mean, that's not how you spell Eiffel for the Eiffel Tower, but it does have Phil in it, and I kind of wanted that, so I thought that would be fun. And then after the fact, I decided that it would stand for ECMA script inspired Filecoin implementation. So there we go. Maybe that's work in progress, and we can change it later. So anyway, I got to the power actor, and I've got to the point where the power actor needs a thing called a multimap, and other actors have used a map before, like it's a hash array mapped tree, and Rodvag has actually implemented that in IPLD. It's not quite compatible with what the layout that Filecoin's using, but he's very kindly documented the differences, so that I'm hoping that in some point I can make the changes as not a PR, but a fork of perhaps of what's there, or extend it in some way to allow me to change the layout accordingly. But I'm using just the vanilla one that he's written at the moment, and we'll get it compatible or compliant later. So power actor, so other actors have used a HAMT before, and that's fine, but the power actor is using what's called a multimap, I think it's called, and that's essentially an array of HAMTs, and the array bit is an AMPT, like an array mapped tree. So we have a HAMT and an AMPT. I don't know if people normally say that all as one word, or AMT or HAMT. Anyway, so with all of this, with Eiffel in general, I'm not trying desperately to implement things very differently to how they're done in Go. I'm trying to do them very similarly, with, but obviously having to work within JS data types and things, and sort of making some there's a like occasional bits that are Golang-y into more idiomatic kind of JS style things, and for the most part where there are differences, I've tried to document them in this docs kind of differences document. So there we go. Anyway, so today I've been working on implementing this AMT IPLD, which is a port of this Go AMT IPLD. I've ported pretty much all of it now, and there's tests and code curve and all of that running. So that's good. I'm just porting the tests. So today I'm going to just do some pretty mundane porting tests from Go to JS. But let's have a quick look at how you use this. I found out recently that you can get CID from multi formats now, and it's not the same as the one from SIDS, but whatever. So the AMT, it needs a store, like an IPLD, like a CBOR store, and it's really simple. It just needs, it's a get. It's an asynchronous get operation which takes a CID and returns a value of some variety, and a put which takes a value and returns a CID for that value. So that's pretty cool. That's easy enough to pass in. So we can import the AMT like this. If you want to create a new one, just new AMT, pass it to the store. I think in Filecoin the bit width is by default 8. We'll maybe talk about bit width in a bit. If you have an existing AMT, then you just need to give it the CID of the root node in the AMT. Obviously passing the store as well, and ideally you will pass the same bit width as it was created with, for verification that it's the AMT that you were expecting. And then if to actually use this, so you've got to remember this is kind of just an array. So we've got I've got my type, my fruit type, my fruits. So you can think of this as just an array of fruits. And then the whole point with AMT is that you can put arbitrarily kind of large numbers of items in them. So we're using big int as the indexes, and in JavaScript, if you want a literal big int, then you put n after the number for nobody knows. So if you want to like set an index, then you can set it like this: index and then the value, index value, index value. And I've put like, this is purposely sparse. It can be sparse. So I've just put 0, 1, and 3 to kind of show that when you've put those things in, the size will be, it will tell you how many elements are in that array, not the length like in JavaScript arrays. If you have a sparse array, then the length will always be the last item, not the last item, the index of the highest item in there, if that makes sense. So then we can try and get hold of these, and I've tried to get the missing one here, assign them to these values. These are all asynchronous operations because they talk to the store, because there's lots of kind of sharding going on, and stuff like that. And here we go. So we can see that we can log out those values. F2 is undefined because there was nothing. So if you try and get something that isn't there, it doesn't throw, it just returns undefined. And I think the unspoken part about this is that you don't ever put null or undefined in it. I think it just does not support that, and it cannot be serialized by DAG-CBOR, or undefined can't be serialized by DAG-CBOR right now anyway. So there we go. You delete things if you don't want them. So, and then the AMT is a async iterable, so you can iterate over it. There's also a you can call fruits.entries to do the same thing, but there you go. And so once you've mutated it in some way, then you need to call flush so that it can store stuff in the data store, because otherwise it might not have saved all of the things that you've been putting in it, and that will give you back a root CID. That's pretty cool. And then so that's basically it. There's not a lot much more. There's a delete. There's the delete function for deleting keys. That's pretty cool, huh? Yeah, one thing I should explain is like encoding and decoding CBOR things, but I might leave that for another time, because let's get on with doing some test stuff. So I'm kind of halfway through this, so I've got a load of tests here. These are so in all of IPL, I've been putting tests in with the source, but in a folder called tests, so that it doesn't clutter up the actual tests. And that's quite so. These folder names are quite common in JS land nowadays. And so root.spec is the same as so I've got there's a root.ts file here, which is kind of similar to, or it has all of the code from AMT essentially in it, but the AMT.go has only this root struct in it with a whole bunch of functions that operate on that struct. So I've called that root in JS land. I have made some arbitrary decisions regarding naming and stuff, but for the most part it's kind of, once you've seen it, it's done. So AMT test is loosely this file root.spec, because the tests are gone in the test folder, and I've named it after the file name that it's testing. So I've got a bunch of tests. I think if I can comment these out already. Actually, you can see them just down here. I've already been running a few of them, which is kind of cool. So the way I've gone about this is to essentially take a bunch of Go code, copy it into the TypeScript file, and then convert it to JS. And so I'm halfway through converting this test called Chaos. So that's a fun name. So there's some there in the Go code. There's a seed, a random seed. We don't really have that in JS land, so I've kind of commented that out. Then there's some numbers here, which I'm guessing are some seeds where they noticed some test failures, which they've put in there to ensure that they were fixed for that particular seed. I'm guessing. So that's that. I've kind of just commented that out because I can't really replicate any of that functionality in JS land. And so I've got down, like this is, let's have a look at the actual test here. So these are the seedy bits. Then there's creation of the AMT. For us, that's a new AMT class. There's no, because JS doesn't return errors. I mean, it does if you're using callbacks, but we're not using callbacks. So we're using promises all the way down. So there's no, I never, whenever Golang asserts that there's a no error, then I don't add that in, because it'll just be thrown if there's an error, and then the test will fail. Obviously, so there's no need to assert on that really, unless there's some sort of message that I want to add to it, or because otherwise the code isn't doing any other assertions. So what it's doing is it's creating a new empty, it's flushing it, which gives us the CID of an empty array, basically. And then there's some stuff going on here, which is this is where I am at the moment. So let's have a look. Go back here. I've created my new AMT. I can give it a type. So in general, arrays, you normally put things in of the same type. You can just leave this out because it defaults to any, or put any in there, whatever. But it means that when you do a.get, then it'll give you back a string, or a promise of a string in TypeScript land. So you can use strings and not have TypeScript complain at you, and not have to do casts and stuff. So right. Anyway, so I've just got like basically condensing this for loop down. So we've got range ops. So before they'd created an empty slice with a size, and then so this is getting hold of the nil op. I'm not creating a type for this. I'm hoping that, yeah, so TypeScript's going to sort me out here and just create a type for it dynamically, which is good. So we've got IDXs. That's making a slice of numbers and then getting some random size of slice. Yes, okay. So here we go. I need to do I'm using this. I'm just going to create a function to do this, to help me with this, so that there's less to do. Actually, there's a good one on MDN. And I just crib whenever I need. So there we go. Random. So let's choose to random int min max. There we go. Oh, we don't want arbitrary, do I? I actually want this. The min is inclusive, the max is exclusive. Yes, that's what I expect. Good. What's the number? That number, and then real good. There we go, and this makes things a whole lot easier. Okay, so they're doing a random max per op, so random integer between, okay. Max per op, and then they're iterating over the empty array and adding a random okay, so that's a random int between 0 and max index. Oh yeah, I put an extra e in the variable name because it felt like it was unnecessary to not have for the sake of one letter. There we go. Right, so we've got our ops array now. That's nice and full of stuff. Test map. Okay, so that's a map of numbers to empty struct. So is that a set? Maybe that's a set. Let's assume it's a set for now. Set, and that's what are we putting in there? Index. Oh yeah, so they're big ints going in there. They're the indexes of. Hang on, what's going on here? Const. Okay, I think I didn't need that. no, that's fine. It's my array. That. Oh, yeah, and then another. There we go. Okay, fun times. So let's leave that out for now. And then we are doing for const IO of ops.entries. Okay, so const load AMT. So we don't need that. We will do equals AMT.load. Yes, we have a static property of AMT instead of load AMT. No errors, don't worry about that. And then we want to iterate over the indexes, the values of o.indexes. Okay, cool. Index of o.idx's. Cool, great. If not delete it, okay. Set. I haven't used any context in this. I'm assuming we can, if we need that, we can just add it in later as a abort signal. A.set. Huh. Oh yeah. So loading, you need to await because it needs to load it from the block store. Right, index. Okay. Yes, because it's meant to be a big int, isn't it? Let's just make it a big int. There we go. Add it to the map. I'm going to rename that later because it's not a map. Right, okay, so if you're not deleting, then do that. Otherwise, delete this index. What I might do is and then we don't need to worry about doing this all over the place. Okay, so delete it. So test map delete index. Thank you. Oh, okay. Here we are. Let, right? Correct len. Okay, so okay, so sets have a size property which tell you how many items there are in the and there's a number. And so instead of, so there is a function called len on AMT and Go. I've changed that to size because maps, well, so like I said before, arrays in JavaScript, their length property is not the number of items in it, it's just like the maximum index, which is no good. So I think to counteract that, sets and maps in JS, like the native ones, all have a size property, or both have a size property. So I've cribbed from that and made the AMT have a size. It's a getter, and it just returns the number of items in the AMT. So yeah. Okay, failed, true, okay. I think we should probably use a t.is a.size is actual expected, and then we can put that message can't we? Correct, so correct then count is a dot size. We're not going to use size. And then I is I, whatever I is. Okay, so we've already got an I here. Okay, so let's change that to just IDX. So I guess they are not failing the test just yet. What does error F do in test land in Go? Log F followed by fail. Okay, but what does fail do? G.fail. Didn't not fail now, so I'm assuming that marks the function as having failed but continues execution. Okay. I mean, that is what assertions do in Ava anyway. So maybe I'm not gonna use that. Oh, where is that? Here we go. I'm probably not going to use that boolean, so let's not do that. Okay, so the CID is now await a.flush. Oh yeah, so most of the function names in JS, I've changed any capitals at the start to be lowercase, so it's a bit more idiomatic. Same thing with properties, of even for state and stuff. It means that encoding and decoding CBOR is a bit more laborious because we have to convert between these uppercasing and lowercasings. But I think for when you're actually using it in JS, it's a bit easier. And I'd rather not have this kind of weird JS Go hybrid language where things are not quite JS or Go. So it's been normalized in that sense, at the expense of possibly my sanity. Cool. So const a load. Okay, so we just what? A.flush. Oh, what's happening? Or is it being redeclared? Is it? Oh, okay. So what's this one doing? We've got an empty CID there. We're using that somewhere? Doesn't look like it. Have a look. Oh, here we are. So it is. It's loaded here. Interesting. All right. Well, I guess what we can do is we can have a let. So these are doing this. Oh no, C. Okay, every time we go around this. Oh wait. Just ops. Yeah. Okay. Every time we go around, we do update that C and that A. Okay. Fine. Fine. Okay. If that's what's happening, that's what's happening. There we go. Hopefully that is okay. So no error. Maybe we should call this correct size. Flush. Bad size after flush. Correct size. I. Okay. Good. Good, good, good. Okay, FE count, that's great. So and then we're just going to do for each. We don't have for each, we just got this entries, or it's iterable, so you can just for await. We don't care anything, do we? Of 8, I think it is, and then we just FE count plus plus. There we go. What's wrong with that? Okay. There we go. Okay. And so if okay, we're back. I have coffee and have eaten biscuits. So sorry about that. Okay. So I'm destructuring but not assigning anything to any variables because we don't care about them. So this is just testing that the iterator will iterate over all the entries and the size. So the size is independent of this. The iterator actually traverses the tree. Size is just maintained as things are added and removed. So size should always be correct. But if there's bugs, or if it reads a tree that is bad in some way. Anyway, so after iterating all of the entries, it should match the correct size. So the FE count, I'm going to call what should we call this? That stands for each, I think. Let's call it the it count. It count. What's wrong with that? Oh, okay. So what did he say? So bad. Okay, I'm going to get rid of all of that stuff. Okay. I got underscore somewhere. Where is underscore declared? Okay. Oh, okay, how am I going to do this? What is wrong with this? Oh, because they're both underscore. Oh, I'm having a complete mind blank about how I'm going to be able to do this. I just don't want anything. Maybe just one. Please leave me alone. Okay, cool. That's that. Okay, that test is good-ish, I think. Let's see if it runs. Hanging. Nope. Timed out. Okay. Wow. Well, that's not good. Where did we get to, though? Oh dear. indexes. Okay, so let's have a look. Did we get here? Did we do one iteration? Yes, we did many iterations. Okay. Is it just taking a long time? Timeout? Set a timeout for the test in milliseconds. Okay. So let's say a minute. Oh. Okay. Interesting. Okay, maybe Ava has got some sort of global timeout above. No. Here we go. There's a whole section for it. Okay. Alright, here we go. Mm-hmm. 2 minutes apparently. Maybe this is just taking a while. Ops, so it's 1,000 ops and 1,000. Wait, max per op. Oh, yeah, see, it worked. 22 seconds. Okay, cool. Maybe that can be less. Chaos, 22 seconds. How long does that take in Goland? That seems to be a long time. 2. Well, that's not good, is it? But it still passed, so I guess that's okay. Alright, well, I guess we can just leave that for now. Maybe I will add this random thing as a helper. If we need it again, then we can use it. Fix me. Okay, cool. So that's working. That's good. On to the next test. Insert a bunch with delete. Okay. Wow, oh, this looks long. There are a lot of tests here, so that's good. And I did about like 5, maybe 3 to 5 tests and covered about 75% of the code, so that's good. I'm very glad. There's such extensive testing. Test insert a bunch. Glad we're all serious professionals here. Insert a bunch. Okay, with delete. Rad. So this gets reduced down to just. Yeah. With any luck, we won't be reassigning. Okay. Oh, I'm glad we brought that out as a function that we can reuse. Hooray! So number origin set. So this is a map of number to Boolean. Okay. Remove set. Remove set. Maps. Before it was maps that were actually sets. Okay, so that's fine. I'm wondering if origin set. Okay. Yeah, I think we don't need the Boolean actually. They're not using it at all. Yeah. Okay, so this is going to be a new set of number. I'm guessing that will probably turn into big int. This is the same. Seeds, randomness, no, cannot have. Okay, and yep, for I equals 0, I is less than num I plus plus origin set dot add random integer between 0 and num. So I guess we could generate the same random integer more than once. That's okay. I mean, that's what's happening in Go. So whatever. Okay, and then for I is less than 660. K is a random integer between 0 and num. If origin set dot has K, then remove set dot add. Okay, so if we've put a random number in the origin set, then if we generate another random number that happens to be in the origin set, then add it to the remove set. Okay, so it means we're only removing stuff that is in the origin set. Great. All right, what's going on here then? I is less than nums on this again. 22 seconds, that is not cool, is it? I have to figure out what's doing that. So there's some differences. The store that we're using, I've just created a mem store. I do believe the digest for CIDs, yeah, so this is, it's in Go, it's using this Blake2B. I don't know if that's way faster than SHA-256. But I think it's, other than that, it's similar. I can't think of anything with this that would be a performance bottleneck right now without instrumenting stuff in some way. So anyway, if origin set has I, then what are we going to do? Okay. Big it. Full baba. So we're going to assert. So we're going to this assert set is a helper that does a calls set on the root on the AMT and make sure it doesn't throw. A little bit. Doesn't really do a lot. But then I guess we might want to do some asserts at a later date. Anyway, so assert set, that's great. We put stuff in it. I don't know why we're, maybe they are iterating like this because if they iterate over a map in Go, it'll randomize the keys. Whereas it's not the same in JS. I'm just wondering why they're not just iterating over this set and calling a set, and I think that's probably the reason why. So we can probably just do like for const I of origin set dot values return the interval of values in the set. Rad. There we go. Then we don't have to do quite so much work. Okay, that's what I've just done. So it's set. And then they do it again, but forget. Okay, fine. A.flush await no context const yes if error then it throws, so that's okay. Await not error it throw. Okay, so same. Okay, so this might not be what I thought. Because they're traversing, adding the values in order. I don't know if that will result in a layout, different layout. Possibly, right? I'm afraid I don't know the spec of how this thing is laid out well enough to say. So let's stick with what was there. If origin set dot has I, then set it. Fine. Then it's exactly the same. Stop being clever. Just get on with it. Get. All right. So we're doing it again. But if the remove set has it, then delete. Great. That's going to be let because we're reassigning to it again. In a await flush. Okay. Just like make up your mind. Are you gonna have new variables or start reassign? Do one or the other. Okay. This is where sprintf comes in really handy. So I've got this ongoing question in the actors code base about whether I think I've been using, there's a module called sprintf, which I've been using, but I'm just wondering if it's more performant to use template strings or not. Probably not. Oh, I don't know. Anyway, if we're just logging stuff out, what is that noise? Removes size expected is origin minus remove. Okay. Yeah, and actual is NA2. That line. Assert count. Okay, so I changed this because we don't account. The call is called len, so I don't know why it's called len. Assert count. Oh, because I think in Go it's inspecting the count. There's a property called count, which is essentially what we're calling size and what they're calling len. So set size. This will have to be a cast to a big int. So size minus. So this is what we did above already. Okay, right. That's not async or anything. No. Okay. So then we're doing that loop again. If oh, okay, here we go. If origin set dot has I and not remove set dot has I. Oh yeah. Get begin. Okay, makes sense now. Now my tests are all going to take 30 seconds. That's annoying. Okay. Wow. Expected 711. Oh, that's not good, is it? It's interesting that it ran that one before. Huh. Wow, so it's not removed all of the things that I wanted it to remove, so that's not good. Yet all of these seem to pass. There's no failures. So a bunch of okay. Hang on, so is this 415? Is that 719 plus 415? Okay, right. So it's not deleted anything. Interesting. Did these assert deletes run? If remove set has I, then assert delete. Deleting is not working. mt.load, okay, na.flush. Maybe let's should we log out the CID before and after the deletes? I imagine it's changed. Although I guess it hasn't changed. Well, there you go. Did it do any delete? Do a delete. Yeah. I should see like 400 do a deletes. Yeah, okay. Interesting. Yeah, they're the same each time. So even though we've done deletes, haven't we got a test for deleting stuff? This is weird. Deleting, is it? and get set and get. Deleting is working here. And assert delete is deleting, making sure it was deleted or it was found, it was in there, and then getting it and making sure that it isn't in there anymore. Okay, what the Jeff? T-A, is it A? Oh. Maybe if I delete it from the right. From the right AMT, that would help. Okay, okay, let's see. Yes. Yes! Perfecto! It's too slow. Okay, but I know when I think we should probably let's commit these tests. More tests. Cool. Okay, so I'm interested to see how much more code cover we've got out of those tests that I've been writing this morning. Shoot, I'm hoping this will just pass. Let's leave that for now. Let's grab the next test. Let's grab the next test. Let's get that's what it's done. Insert a bunch with delete. It's done that, right? Oh yeah, test delete first entry. That means we're gonna have to get the first entry. Right. Yeah, so super interesting that it ran in this order. Maybe it kind of orders them by, it remembers and orders them by time or something. So my understanding is that Ava will it runs tests in parallel if the tests are in separate files. The ones in the tests in one file, it will run sequentially, but that doesn't seem to be happening. So this is interesting to me. Test first entry. Let's grab hold of our Blockstore and our AMT. Set 0n27. Put some cats in there. That look good. I said delete that cat. Get the CID. Yeah, usually if I manage to port the tests correctly, then it's quite easy. It's quite quick, but for more complicated tests, if they're like, it's way easier for like little little errors and things to sneak in, and then that sinks a whole bunch of time. Don't know why my laptop's being so slow. There we go. Let's count. That doesn't exist, does it? That's a size. One, no. Delete first entry. Okay, run the test. Oh wait, that's not what I wanted. Oh, hold up. Nice. Seconds. Oh God. 83 from 75. Wow. That's what I'm talking about. Look at that. Brilliante. Yeah, I don't know what the test coverage for this is. It is not clear. Oh no, things are changing. Whoa, okay. Right, delete order independent. Okay, this is cool. More tests. I will update my... Oh, I'm on a branch, aren't I? Did I get... Oh no, because this is a fork, isn't it? Oh. Okay. Okay. Cool. Got them. Dispatch. Show me hand. I wonder what the benchmark said. Does that get run? No. How do you run benchmarks in Go? I can't. You could look at that, but not now. Okay, so delete first entry did that. That didn't pass. Okay, great. Oh, because I'm not waiting for things to happen. I'm sure this will work now. Yeah. Delete. Delete first entry. Oh, yeah, it's passed. It passed ages ago. Okay. Delete first entry. That passed. Hooray! Test delete. This looks fun. Oh god. Yeah, in general, I'm not being too clever with changing stuff. I don't know. I think I said this at the start, but part of this is that I do want to be able to take updates and changes from the Go side of things and apply them to JS, and it makes it so much simpler if you can sort of find the same bit of code and apply changes to that piece of code rather than have to kind of figure out how the world works in JS and or Go and do the same thing, and it's going to be a bit more error prone to be doing that. So being able to apply the same change, I think, is going to be helpful. Okay. Yeah, as far as I can tell, there's no new SQL store in JS, and the concept of a block store is not really a thing either. So I've just created this mem store which complies to that interface that I was talking about a while ago. Check that deleting out of range of the current AMT returns not found. Okay, yeah, fine. A.delete. Oh wait. T.false. Found. D. Okay. We need some awaits here. So delete. Trying deeper operations now. Sure, whatever. I would love for there to be a linter which says, you didn't put an await in front of something that returns a promise. There probably is one, but I have not looked for it. Oh, see? Oh. Load. Wait a minute. That's new. Oh wait, 24. When? Okay. Oh, if C is not equal to A2C, okay. T dot true, C dot equals A2C. Yeah, we can't compare because CID in JS is it's like a class instance, and in Go you can compare two structs using equals, the equal sign, and not equals like this. And they will be equal if they are the same structure as well as the same values in each of the parts of the structure, even if they're not the same instance. And in JavaScript, you cannot do that. You can only do that with built-in types or primitive types like number, big int, strings. So our CIDs being a class, we can't just do C equals C2. So we have this comparison function, which allows us to tell us if this CID is the same ish, like the same, pretty much the same, but not necessarily the same instance as the other one. So I don't know how useful this stuff is. So this is percent hash v. Is that like the address of? I don't know what that hash bit does. I'm just gonna leave it like that for now. Okay, things happened. Let's run the test. Delete. Ah, cool. Okay, it's passed already. Sweet. Maybe I'll remove that trying deeper operations now message. And I wonder if the other message. Oh, okay. Maybe I could just not necessarily print that out. Into a dot size, and then expected size is going to be this. This can be the assertion message. For in case things don't work. Oh. But otherwise, if everything is fine, I do not care about that. Delete reduce height. Okay, I'm going to do one more and then call it a day for now. Because this is pretty mundane. It's only when I run into problems when things get interesting. So, async t, there we go. Set 1n thing flush. Yeah, c1 equals await flush. And there's certain things that I am doing over and over again that I should just copy the whole thing in and do a big replace all. And I have done that before. I'm not sure why I'm doing them one by one. I don't know. So, const load. C2, it's all good, it's all good. Yeah. C2. What's wrong with that? Oh, okay. I have to say, TypeScript has been really helpful. There's no async stuff happening in the size assertion. C3 is await a2 flush. I am okay. T dot true. Yes, they should have some sort of canonical form. Oh. Delete reduce height. Delete reduced height. Okay, so it worked. That's great. Perfect. Okay, so alright, I'm going to say goodbye for now until we have another exciting Eiffel Diary entry. Hee hee. Goodbye.